From the problem statement, we understand that neither the front view nor the top view can be drawn directly for the given position. Therefore, we assume the solid is initially resting with its base on the HP as shown in the figure. For this assumed position, we can draw the top view, which is a hexagon, and the corresponding front view is a rectangle whose width can be obtained by projecting the top view. Therefore, first we need to draw the top view for the assumed position, draw the XY line, and draw the hexagon and name the points as shown in the figure. Notice points A, B, C, D, E, F are at the bottom, therefore they are put within bracket, and the points G, H, I, J, K, L are directly above A, B, C, D, E, F and nearer to the observer's eye, and therefore they are put G, H, I, J, K, L itself in small letters. How to construct the section? You can refer the previous problem we discussed already. After drawing the top view, obtain the corresponding front view. Project each and every corner point onto the XY line, and the height of the solid is given as 60 mm. So therefore at 60 millimeters draw a horizontal line and name the points A dash, B dash, C dash, D dash, E dash, F dash at the base, because those corner points are resting on the horizontal plane. That's why we obtain those points on the XY line itself. And the top corner points are G, H, I, J, K, L. And I hope you understand the visible and invisible point concept. So the invisible points are put within brackets. The top view and the corresponding front view for the assumed position. Solid hexagonal prism lying on the horizontal plane with its base. But in this position, the axis of the solid is perpendicular to the horizontal plane and parallel to the vertical plane. The actual position given in the problem, however, is the axis is parallel to vertical plane and inclined at 60 degrees to the horizontal plane. Therefore, this is not the required front view. But the size and the geometry of the front view of the assumed position and the actual position are the same, only their orientation is different. Therefore, if we reorient the front view to the required angle, that gives the final front view. That means the front view corresponding to the position given in the problem statement. For that, we assume the edge DE is going to lie on the horizontal plane. So when the edge DE is lying on the horizontal plane, definitely it is perpendicular to the vertical plane. Therefore, its corresponding front view appears as a point. So that point is D dash E dash in the front view. To reorient the front view, mark point D dash, E dash at any convenient location on the XY line, and from that line draw a 30-degree line and obtain point A dash and B dash. So to differentiate between the assumed front view and the final front view, we used the suffix 1, that means A1 dash, B1 dash, D1 dash, E1 dash. So the length of the line can be measured from the front view corresponding to the assumed position. So measure A dash, E dash in the front view and transfer the distance at 30 degrees. Why 30 degrees? Because the axis is inclined at 60 degrees as given in the problem statement. Therefore, the base must be at 30 degrees because axis is perpendicular to the base. Now we want to mark this point J dash K dash. Therefore, draw a 60-degree line and transfer the distance 60 millimeters. So D1 dash to J1 dash distance is equal to 60 millimeters and the angle is 60 degrees, meaning the axis is inclined at 60 degrees to the horizontal plane. After obtaining this J1 K1, next aim is to obtain G dash H dash. Therefore, from J1 dash, draw a line parallel to this 30-degree line and obtain point G1 dash H1 dash. So the distance between H1 dash and J1 dash is equal to the width of the rectangle. Now join B1 dash and H1 dash. What is remaining is C dash F dash, I dash L dash. For that, measure the distance between D dash and C dash. So measure this distance and transfer the distance in this rectangle. So from point D1 dash and obtain point C1 dash F1 dash. So C dash F dash, instead we have put C1 dash F1 dash. And from C1 dash, draw a 60-degree line to meet H dash J dash and obtain points I1 dash L1 dash. So therefore, we oriented the front view obtained for the assumed position at 60 degrees to get the final front view. So what is left? We need to obtain the final top view. So how to do that? Follow the projection technique. To draw the final top view, project from each and every corner points in the front view and each and every corner points in the top view corresponding to the assumed position. So now we need to locate the different points. We'll try to locate the points corresponding to the hexagon at the base. So it is A1, B1, C1, D1, E1, F1. Out of the 6 points, D and E are the points touching the horizontal plane, and when we look from the top, they are hidden by the solid at the top. Therefore, they are invisible and hence put within brackets. Similarly, we can locate the different corner points corresponding to the hexagon at the top. So G1, H1, I1, J1, K1 and L1. So these points are located as per the discussion we made in the previous problem. Again, for example, suppose if you want to locate this point C1, follow the vertical from C1 dash, follow the horizontal from C, and both of them intersect at C1. Similarly, other points. Now we can draw the hexagon at the bottom and also at the top. So the bottom hexagon A1, B1, C1, D1, E1, F1 is drawn by joining the points in proper sequence. The sequence is A to B, B to C, C to D, D to E, E to F, and F to A. Out of the 6 edges, 3 edges are drawn using discontinuous lines because the points E1, D1 are invisible, and hence the corresponding edges are also invisible. Similarly, we can draw the hexagon at the top of the prism. So that is G1, H1, I1, J1, K1, L1. So the top hexagon, all the edges are visible, represented using continuous line, because those edges are nearer to the observer's eye. So the final step left out is to draw the vertical edges, or the edges corresponding to the rectangular faces of the solid. So as a guideline, the solid in three-dimensional form is shown here, but remember, this is an assumed position. It is shown here just to easily visualize which point is connected to which other point. To start with, point A is connected to point G. So here A1 and here it is G1. So join A1 G1. So both A1 and G1 are visible points, therefore it is a continuous line. The next one is B to H. So B1 is here, H1 is here, both are visible, continuous line. The next one is C to I. So C1 is here, I1 is here, both are visible, continuous. So the next one is DJ. So D1 is here, J1 is here. Out of these 2 points, D1 is invisible, therefore dotted line. EK. So E1 is here, K1 is here. Out of these 2, E1 is invisible, therefore dotted line. And the final point is FL. So F1, L1, both are visible, therefore continuous line. So this is the final top view, and this completes the problem. So what is the difference between the one we discussed earlier, that is problem number 1, and this problem number 2? In problem number 1, the same solid was resting on the vertical plane with one of its base edges on it, and in this problem it is resting on the horizontal plane with one of its base edges on it. So that is the only difference, maybe the dimension and angle. Therefore, when a solid is resting on vertical plane, start drawing assuming it is resting on the VP, and if the solid is resting on the horizontal plane, Start drawing assuming the solid is resting on the horizontal plane with its base on it. Thank you.